The steam engine may seem to be a relic of the past in a world powered by diesel engines, gas turbines, and nuclear reactors. However, the real world would be a very different place without such a game-changing technology. The steam engine, perhaps the most significant invention of the Industrial Revolution, facilitated great improvements in mining, production, agriculture, and transport. Although several prominent figures from the 18th and 19th century are credited with inventing and improving the steam engine, steam-powered engines have a nearly 2,000-year history dating all the way back before the Industrial Revolution. The earliest mention of a steam engine goes back to the 1st century AD, when Hero of Alexandria described the Eolipile for the first time. More than 1,500 years later, Taki Alden in 1551 and Giovanni Branca in 1629 described the simple forms of turbines powered by steam power. That's either a small steam jack or an escapement machine. They were mostly used by inventors to demonstrate the importance of steam power engineering. Miners faced a major industrial challenge in the 1700s, which was due to the exploitation of water from deep mines. The real strength of steam was demonstrated at this time, when the energy was used to drain water from deep inside the mines. The potential strength of steam was realized as a result of all, resulting in the development of a full-fledged steam engine. In the modern world, steam-powered electrical power plants were built later. Condensation of water vapor to create a vacuum was the fundamental concept behind the first steam engines. It would later rely on steam's increasing strength to push pistons in both directions. In 1698, Thomas Savory was the first to invent a steam engine for the purpose of extracting water. It was named water by fire by him. He invented a steam pump that operated through heating water until it became fully vaporized. The steam was then stored in a tank, and extracted all of the vapor from the original tank, resulting in a vacuum in the container. This vacuum was used to provide enough energy to drain water out of the mines. This proved to be a temporary solution since the energy could only draw water from a few meters deep. Another disadvantage of this pump was that it used steam pressure to drain the water being drawn into the tank. The pressure was too high for the boilers, and many explosions happened as a result of the weak boilers. Thomas Newcomen invented a practical and effective steam engine in 1712. A piston and cylinder arrangement were connected to a pump through a rocking beam in the steam engine he built. The Newcomen atmospheric engine, like Savory's, used condensing steam in the cylinder to create a vacuum. The resulting pressure difference between the vacuum and the atmosphere was enough to force the piston into the cylinder and lift the pump. The piston would then be drawn back up in the cylinder by the weight of the pump, and a valve would open, releasing steam from a boiler. Another valve would then introduce condensing water into the cylinder and the vapor would condense again to water, repeating the cycle. For more than 50 years, the Newcomen beam engine was used as a pump for coal mines that would otherwise have flooded and been lost. They turned out to be inefficient since the engine took a lot of energy to operate properly. Every cycle required the cylinder to be heated and cooled, consuming the most of its energy and resulting in significant waste. Finally, James Watt revolutionized the steam engine by introducing a separate condenser into the system. In 1765, he created a different condenser. Just 11 years later, the design had become a powerful steam engine. The condenser prevented the cylinder and piston from being alternately heated and cooled, as in the Newcomen engine, resulting in a significant improvement in performance. Boring of the large diameter cylinders used was one problem that's been fixed. John Wilkinson developed a boring tool that was held on both ends rather than cantilevered, allowing him to bore reliable cylinders up to 50 inches in diameter. As a result, the piston was properly sealed against the cylinder walls. Technology has improved significantly. Watt's engine was licensed based on the amount of fuel it saved. Jacketing the cylinder and developing a parallel linkage that enabled the piston to push and pull were two more developments. This would open the way for rotary motion, and the eventual replacement of water wheels as an industrial power source. Watt considered high-pressure steam but discounted it because he believed that the boilers of the day were unable of managing those pressures. Watt also invented a method of measuring pressure versus volume in a cylinder, which resulted in the well-known PV diagram, which is still in use today.